So getting too excited with prototypes and almost believing the prototype is the end production ready solution. So it's always good to understand and contextualize that a prototype has been built within a certain context to cater for specific use cases. But production readiness is actually everything else, all the edge cases, all the unforeseen scenarios and things that might arise, or even adversarial attacks, etc. So that is what production readiness is all about.
Welcome to Inside the Algorithm, the show that goes beneath the surface of artificial intelligence into the scientific research, technical breakthroughs, and academic thinking shaping where this technology is actually heading. I'm Jeremy Bradley, Chief AI Officer at Cambridge Spark, a leader in transformational data and AI upskilling, career development, and progression. Each episode, I sit down with the researchers, data scientists, and technical experts working at the true frontier of this field to explore not just what's happening in AI, but also the real science and thinking driving it forward. Whether you're building sophisticated AI systems, leading teams through AI transformation, or driven to understand what's really happening beneath the headlines, this is the show for you. In today's episode, we're examining something that doesn't get discussed honestly enough: what it actually takes to ship ML in regulated industries and what happens when you bring that mindset into one of the largest insurers in the UK. My guest is Alberto Romero, Director of AI Engineering at Aviva. He co-founded and served as CTO at Human AI, an InsurTech startup building ML risk prediction systems for the commercial fleet market and growing it to a Series B before its acquisition by Aon. He then led generative AI platform engineering at Citi, delivering several production RAG pipelines and an AI agents platform to more than 25,000 daily users. From there, he founded Jointly, a startup focused on building AI agents for regulated industries through systematic optimization and reinforcement learning algorithms before joining Aviva, where he now operates at a very different scale. In this conversation, we get into what that transition demands of an engineer, how MLOps changes when it becomes an organizational problem rather than a tooling one, and what it genuinely takes to get generative AI right in an environment where the decisions are consequential, the data is complex, and the regulatory landscape is still forming. I hope you enjoy it. Welcome, Alberto. Lovely to have you.
Thank you very much. Yeah, really, really nice to be here, Jeremy. Thanks for the invite.
You spent a better part of a decade, I think, building ML systems that get used. So in many sectors, mobility, banking, now excitingly insurance. So the narrative around AI in regulated industries has tended to be slightly mixed, shall we say, in terms of sometimes adoption. And so, whether it's too risky to deploy or, maybe getting slightly overwhelmed with pilots and never quite getting to that final use in use story. What's your sort of take, I suppose, on how you've avoided those kind of pitfalls?
Yeah, I mean, I think things have materially changed with Gen AI, because I think with machine learning, with traditional machine learning, the risks were well understood. That's quite ingrained within the many of the largest organizations in the world in terms of predicting risk and that kind of thing. But yeah, it's more from a Gen AI perspective, the non-deterministic nature of the beast, right? And that's sort of that's brought in another level of sort of concerns around risk that they might bring, or that the use of LLMs might bring into the mix, for all the right reasons. So yeah, there's a whole trend, and it's probably starting to fade out a little bit around this is too risky to implement, etc. But that's a natural fear to sort of not understanding what is possible, or how you can actually circumvent the non-deterministic nature of LLMs by adding the right controls and setting up the right evaluations and metrics and measuring what really matters, right? But then, as you said, on the other side of the spectrum, there's a lot of excitement, right, around building prototypes, and even more so these days is really really easy to build a really good looking prototype. You might almost mistake it for something, or some people might mistake it for something that is ready for production, and that's also a risk. So I think there's somewhere in the middle where you have to be cautious around understanding how LLMs actually work and how you have to work with them the minute you integrate them into a certain application or a pipeline or an agent, and also ensure that you build for production grade capabilities.
I know that in many regulated industries, explainability of around these models is a huge issue. And when I look at LLMs, they're actually very good at giving you plausible explanation for how they came up with particular outcomes or recommendations or even decisions. But my sort of back of the head concern is that that wasn't actually the explanation for how it came up with that recommendation, and that actually it's post hoc generating that as a validation almost of a particular output. I'm interested to know whether your deeper knowledge of this sort of gives you some insight into whether that's the case, or whether it is possible to get proper fully fledged explanation out of large language models.
Yeah, I mean that's a great point. Actually, it's almost a bit like when a child is trying to make up an excuse as to why they behaved in a certain manner, and they just making it up on the fly, right? So yeah, in the most naive way of using an LLM, that is certainly the case. It will sort of justify the previous answer on the fly, and again predicting the next token and so on. But yeah, there are ways to circumvent that, and obviously, like using a React kind of approach where you sort of reasoning over a set of actions and bits of context that you have. You can produce that additional reasoning over how you get into a specific conclusion eventually. So it's a multi-step process where in this case an agent would leverage an LLM through multiple calls to actually reach a conclusion, but produce fully traceable reasoning along the way. So that's a good approach to sort of get that traceability and explainability. But yeah, I think it's taken a bit of a while to get to this point, and obviously that is now a well established practice. Yeah.
That's really good to hear, and I think that gives a deal of comfort to people like myself and others who are trying to sort of get good quality large language model adoption ingrained, because I think the trust and the believability and all of the go hand in hand with that explainability, and so getting that as a first class element is just a real bonus, necessity more than a bonus, in fact. So you've recently joined Aviva, and you spent much of your career until now as an early stage founder. So you've gone through something of a transformation yourself in this particular career move. You've gone from maybe building something that's lean and highly focused to operating inside one of the UK's largest insurers. So how's that sort of felt for you, and what sort of engineering challenges has that landed you with?
There is definitely a substantial mindset change between operating in your own startup, and to be honest, I really enjoy that kind of environment because it allows you to pivot and to iterate very very quickly. But there are different challenges, I suppose. So the challenges that you come across at the startup are mostly resource constrained, and you basically you don't have a choice to not release something. You always have to release something, even if you don't have all the information to hand, because you are testing the market, you are validating what might work, what might not work, etc. the challenges at a company like Aviva are quite different. So there's definitely a resource from a funding perspective. Certainly, that's the case. From a like an engineering power perspective, all other organizations, there's always a challenge in terms of getting the right skill set or in-house, etc. So Aviva, as well as every other organization in the world, we all have that same challenge. We all fighting for a very small pool of really good AI engineers. Um, but yeah, I suppose the challenges are more around how do I align and organize and orchestrate all these different teams and stakeholders in the organization to actually be able to deploy this use case into production, right? And how do we agree these are the right outcomes? How do we ensure that we have a platform that is fully governed, that is scalable, that will behave to the right level with customers, etc. I mean, the engineering principles are the same. Like I apply the same engineering principles I've been applying at my startups as well, in terms of being, very meticulous about how you do things, how you implement things like traceability, explainability, and all those kind of best practices from an engineering perspective. But yeah, it's just you just moving the bottleneck somewhere else is my take on that.
I'd like to explore that a little bit. I think I know from my own experience that landing in a large organization has these substantial challenges, and Aviva is running AI across 70 plus use cases. I'm sure it's going to become many more very shortly. But at that scale, do you find that the whole process around managing machine learning and AI tooling stops being a question of technical challenge and starts becoming more sort of process driven or more organizational?
I mean, that's certainly the case, and I think that is there's always a temptation to try and socialize too early in the process and try and find that piece of technology that will solve for all your problems, right? So I think it's important to have your standards correct up front, and so make sure you have opinionated standards to start with, and then just work towards what is the plan to get to the point where we want to be, and that might indeed involve specific pieces of technology or platforms to sort of orchestrate that governance and everything you need to have, as you said, those 70 plus use cases well aligned and sort of following the same principles, standards, and the same risk and compliance sort of guidelines. So so yeah, that to me is the most important thing. Be able to have your set of standards first, and then worry about the tech later, because the tech is going to continuously evolve. So don't try to solutionize too early.
You've previously worked with fine tuning large language models, which I think is a fascinating subject. And you sort of have to get to grips with how you can do that efficiently using sort of parameter efficient methods for that. And obviously, fine tuning is for a specific use case. So, do you see that as something that you're looking to bring to your insurance use cases and the Aviva setting?
Yeah, I think there's always an argument to consider fine tuning as part of a potential use case, depending on what the use case is all about. Depends on the domain. Depends on whether you require a certain level of either domain specialization or even specific sort of terminology to be ingrained within the models that you leverage. So I mean, there are different ways of leveraging fine tuning in your benefit, and obviously you will want to use whichever one makes sense, and not necessarily always start with fine tuning as the default option. Fine tuning is typically almost like um, I wouldn't say a last resource, but it's definitely it definitely requires a level of maturity in the understanding of the use case and what is required and what is expected, and also understanding that just leveraging knowledge from external sources or a RAG pipeline or other kinds of knowledge sources is not going to cut it, and you really need to to get that additional push from something like fine tuning. So, as an example, if you have a very specific way you want to come across to customers, right? And you want to have this almost like personality. Say in the case of Aviva, you're doing claims handling, and you're using agents, and these agents are taking like doing the first notification of loss, so taking calls with customers that potentially have had an accident. Some of the calls can be very specific and difficult to take on that basis, and you don't want that just a machine to answer like a machine, right? You want a certain level of empathy and something that you want to have distinguished as, hey, this is the Aviva way. This is part of our branding, right? uh, Instruction fine tuning works wonders for that kind of thing. Um, so instruction fine tuning will get you that specific approach and sort of consideration when it comes to building answers or responses from an agent, and ensure that you always maintaining that kind of consistency across answers.
I hope you're finding this conversation as fascinating as I am. If you're getting value from the research and technical depth we dig into on Inside the Algorithm, please take a moment to follow the show and leave us a review on Apple Podcasts, Spotify, or YouTube. Every follow helps us reach more of the brilliant minds doing this work and keeping the rigorous, substantive conversations going. You can find Inside the Algorithm on the Data and AI Mastery podcast feed, or watch it on the Cambridge Spark YouTube channel. You will find the links to those in the show notes below. Right, let's get back into it. What sort of win-cost trade-off do you sort of take into account there? So you've got a very nice case study you've just talked about there when you're trying to sort of create a more, ironically, maybe a more human sort of interface to the company. What sort of data set would you need to collate to be able to efficiently train or fine tune the LLM to have that tone? What sort of effort goes into it from your team's perspective to bring that about?
Yeah, so there are different approaches to this, and it really depends on what you want to achieve. So whether it is the tone and the messaging, and as I said, sort of the approach to customers, the personality, that is typically something that is potentially a little easier in the longer run, because as long as you have the right data set, and by the right data set I mean a set of existing calls that you have labeled and categorized as being really good, and you can just define a data set or extract the data set from it, and you can do the instruction fine tuning based on that. And that typically is something that you don't really need to change all that much over time, because if it's performing well, it's performing well. It's very rare that you're gonna want to have a change in that personality in the longer run, right? It is what it is. Once you get it right, then that's great. That becomes your Aviva model, so to say. If you want to do fine tuning more around the knowledge, for example, so something that is more specific around the domain, the wording, etc., and that is also very very possible that we'll get around doing that kind of thing as well. So you want to use something like LoRa or quantized to change the weights of the outer layer of the model, to sort of define, not fully train a model, but just doing like a quantized approach, a LoRa approach, to fine tuning a model. That is likely to require a lot more maintenance, because your knowledge will change over time. When you have knowledge changing over time, with certain frequency, it can become counterproductive to actually have to refine tune models over and over again. So it requires GPU, and it requires a certain sort of resource over time. Depends on your data set. So yeah, it might be that you just want to use a more traditional, like RAG methodology, or retrieving knowledge from a separate party. But yeah, that's, I suppose, those are the considerations I would have.
So we were very fortunate to have your colleague Sarah Self on Data and AI Mastery recently, and during that podcast with Raoul, she talked about Aviva building its own internal platform rather than just plugging into large language models. That'll enable a lot of the fine tuning work potentially. The fact that you have that internal platform, I know a lot of companies are looking at that sort of trade-off between third-party reliance and internal sort of capability. So do you feel that that's now that's giving you a good platform to build on some of your previous experiences and build on some of the tools that you just talked about, and bring those to Aviva?
Yeah, for sure. I think it was definitely the right call to make, and especially for a regulated business like Aviva, is really really important to have a consolidated way and a governed framework to host agents, and measure agent performance in a consistent and coherent manner across the board. Because otherwise it just creates lots and lots of silos all over the place, and it becomes really difficult to take any use case into production, because every new use case becomes a whole new process to evaluate and validate, and so on. So, and it becomes extremely difficult for, say, risk and compliance. I keep mentioning them, but I'm really like I have a sympathy for them, because it's a really difficult job to do in the times of Gen AI. So I'm very mindful of supporting them as much as possible. But yeah, it's very difficult, because they have to evaluate every use case in isolation. Whereas if you have that level of governance, and you have, for example, metrics and definitions that are common across the organization. So we're going for through these sort of metrics. For example, we are defining specific metrics, and we want the metrics to be defined in the same way across the organization. So if I say advice, is produced by this and this and this factor. I want that definition of advice to actually be applicable to all areas of the organization. So when it comes to measuring, hey, is my agent providing advice and it shouldn't, and what do we do about it? Then we've already walked the walk once, the first time. That's already understood. We just need to, add or adhere to that metric, and just evaluate it, and prove that is working as expected, or our agent is working as expected. So every new business case doesn't become like a completely new thing from scratch. It becomes more of a continuation of what you've been building upon other use cases.
I will, if you don't mind, ask about maybe a specific use case which maybe you've come across, or maybe you're getting to. I don't know in Aviva, but in general in insurance, fraud detection is quite a hot topic, and clearly the necessity to get on top of fraudulent claims is one that all insurance companies will have a very substantial interest in doing. So, do you find that that's a use case which invokes a sort of adversarial machine learning sort of regime? And how do you set up how would you go about setting up an architecture to maybe produce a good outcome, and produce a good sort of predictability and robustness as well to a tool like that, because obviously you get it wrong and it's going to really hurt the customer, it's going to really hurt the reputation of the company. But you get it right, and of course then it has a lot of upside effects. So I'm really fascinated by what your experience has been there.
Yeah, I completely see that as an adversarial kind of use case. I like the idea, like more translating into like GAN networks, so generative adversarial networks, where you have a generator and a discriminator, and you can sort of operate in that fashion. I think that's super powerful. But I think more generally, um, I mean that is a really really good point, and I think it's really important to design for graceful degradation. So what are those scenarios that you can't control, right? And how do you degrade into those scenarios gracefully, rather than keeping them unhandled, and you might just get an outcome you didn't anticipate, and you didn't want, especially in a regulated business, right? And for that, it's super important to have that mindset of sort of being skeptical about overfitting, uh, at sort of the overfitting, when you measure in precision, for example, in the beginning, and sort of be more mindful about how does my model generalize, and is it going to generalize well, certainly based on historical data, but is more about generalizing than sort of fitting too well to historical data. I think that's my take, because that's how you really handle graceful degradation. So yeah, you design for that, rather than sort of be surprised by events and by specific outputs that might be produced in certain scenarios. So it's important to sort of monitor, um, not just the distribution of your outputs, but also the distribution of your inputs, because the world changes. So you've deployed something into production, and the more the world is changing in the meantime, and those inputs might be changing over time. So people tend to focus a lot on sort of observing the distribution of outputs, and seeing the model drifts, etc. But it's equally as important to understand what are those. What is the distribution of the inputs? Is the world changing in a way that can actually impact my model, in and produce an unexpected or undesired outcome? So that's one to watch out for.
So I've got a couple of quick fire questions for you, just to round off. Well, the first one, I suppose, you've built systems around mobility and banking and now insurance. So these are areas and industries where the stakes are quite high deployment-wise in terms of the impact or indeed risk that they might have. If you had to name one failure mode that you see teams repeat the most, maybe not your teams, but other teams, what would that be, and how would they get on top of that?
Yeah, really good question. I would say it's probably uh, so getting too excited with prototypes, and almost believing the prototype is the end production ready solution. So it's always good to understand and contextualize that a prototype has been built within a certain context to cater for specific use cases, but production readiness is actually everything else, all the edge cases, all the unforeseen scenarios, and things that might arise, or even adversarial attacks, etc. So that is what production readiness is all about.
Very good. And then lastly, with everything that's happening in AI right now, what would you think? What development do you think deserves significantly more attention from your technical teams, or technical teams in general, than it's currently getting? Would you say?
So I'd say we need to be prepared to build for scale, for a whole new level of scale, because models are becoming commoditized very quickly. You see open source models coming out that are um, as good as some of the frontier models already, and much cheaper. When they are much cheaper, that means that that's only going to drive many more use cases, and a lot more use of models. You got things like speculative decoding, which is becoming increasingly popular, and is doing wonders for speed as well. So you're going to get a lot more instant responses from models. That's going to drive utilization and penetration of AI across everywhere, and we need to be really prepared for that kind of scale. So I would say a lot of the focus has got to go into building the solid foundations that we all need to be able to scale at that level.
Alberto, thank you ever so much. That's been a really fascinating podcast today. Much appreciated.
Yeah, likewise. It's been a pleasure. And thanks very much, Jeremy, for the invite. It's been really good.
Thank you for listening to this episode of Inside the Algorithm. If today's conversation gave you something to think about, make sure you subscribe so you never miss a breakthrough, and share it with someone who'd appreciate your thinking. If you're a data and AI leader looking to build deep technical capability across your organization, Cambridge Spark is here to help. You can reach us on LinkedIn or at cambridgespark.com. And if you want to explore AI from the leadership and strategy perspective, check out our flagship show, Data and AI Mastery, with Dr. Raul Gabriel Irma. Until next time, stay curious, stay rigorous, and stay ahead of the algorithm.